It's time again for our mathematics program for Senior High School Year 2. Made possible by the Center for National Distance Learning and Open Schooling, CENDLS, under the Secondary Education Improvement Program. This is our fourth lesson on modular arithmetic. Today's topic is constructing addition and multiplication tables in given moduli. Today, I hope by the time I say goodbye, you will be able to construct addition and multiplication tables in a given modulo and answer some simple questions from the tables. Good. What can you recall from our last lesson? Well, let's see. We touched on negative numbers. We learned how to simplify and do subtraction of numbers in a given modulo. In today's lesson, as I stated earlier, we are going to learn how to construct tables for a given modulo. Now, let's start with addition table in mode 4. We will use the concepts of addition and multiplication that we have already learnt in forming these tables. In mode 4, remember we use the remainders 0, 1, 2, and 3. These are 4 digits in all, but 4 itself is not a part. Now, this is how we set the addition table mode 4. We draw a table with 5 by 5 boxes. And in the top row, we have numbers from 0 to 3 with the addition sign in the corner left top box. Then we have the numbers 0 to 3 just below the addition sign. We then fill each of these boxes with the result of adding and converting the corresponding integers in mode 4. Remember, the addition sign is in the top left corner of the table. And we have the mode 4 remainders in the top row and in the left column. Example, 0 plus 0 is equal to 0 in mode 4. 1 plus 0 is equal to 1 in mode 4. 2 plus 0 is equal to 2 in mode 4. 3 plus 0 is 3 mode 4. 0 plus 1 is 1 mode 4. So we do all these additions. And we must make sure that each of our answers is in the simplest form in mode 4. Then, after we have worked all of them, we now have these values and fill the table with them. So now let's fill the table that we have drawn with our answers. As you can see, just below the 0, we have 0. Then we have 1, 2, and 3. Now those are the answers we got for working 0 plus 0 mode 4, 1 plus 0 mode 4, 2 plus 0 mode 4, and 3 plus 0 mode 4. Now, in completing this table, you pick your first number from the top row. Then you come down vertically below the number you have picked. And then you look for your second number right below the addition sign and go horizontally. Now, where your vertical and your horizontal line meet is where you place your answer. And so, for instance, 1 plus 0 mod 4 is 1. We pick the 1 from the top row and look for 0 below the addition sign. Now, where the column under 1 and the row under 0 meet is where we will put our answer, which is 1. Another example, we want to find 3 plus 2 mod 4. Look for the first number 3 in the top row. Look for the second number 2 below the addition sign. Now, where the column below the 3 and the row along the 2 meet, that is where you place the answer. And 3 plus 2 mod 4 gives us 1 in mod 4. So your answer 1 goes into that box. I hope you understand it. From the table, we want to find 3 plus 2 mod 4. So we go to the table, look for 3 in the top row, and look for 2 below the addition sign. And where these 2 row and column meet, we have the answer 1. Therefore, 3 plus 2 is equal to 1 mod 4. Again, we want to use the table to find 3 plus 3 mod 4. So once again, look for 3 in the top row. Look for the second 3 below the addition sign. And where the column below 1, 3 and the row along the other 3 meet is where we will find our answer. And you can see that the answer is 2 mod 4. Very good. We are going to go through the same procedure for the multiplication table. And so we want to form the multiplication table mod 4. Once again, we are using the remainders in mod 4. We will put them at the top of our table, together with the multiplication sign. Then just below the multiplication sign, we'll have our remainders again. Now, the answers that go into each of these boxes is what you get when you multiply the number at the top with the number at the side and convert your answer to mod 4. For example, 0 times 0 is 0. 1 times 0 is 0, 2 times 0 is 0, and 3 times 0 is 0. Now, all these zeros are going in the first row of our table, just below the remainders. Again, we have 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, but we'll have to change the 4 to mod 4, and that gives us 0 mod 4. Okay, so let's skip to 2 times 3 mod 4. 2 times 3 is 6 in mod 4. When you change that, you get 2 mod 4. Again, 3 times 3 is 9. When we change 9 to mod 4, we get 1 mod 4. I hope you worked along with us. We are going to put each of these answers in their appropriate boxes on the table. 3 times 2 mod 4. Find the 3 in the top. Go along until you come in line with the 2. Where the 2 spaces meet, you have 2 as your answer. I'm sure you can see the completed table. Good. So let's take some more questions involving completing the tables. Example 1. Construct multiplication and addition tables in modulo 8 on the set of numbers P equals 0, 1, 2, 3, 4, 5, 6, and 7. From your tables, find 1. 7 times 5 into brackets plus 7. 2. The truth set of n plus n is equal to 6. Now let's look at the solution. We are completing a multiplication table for modulo 8. As you can see, the numbers we are giving are all the mod 8 remainders. So again, we draw our table. Since it is a multiplication table, make sure your multiplication sign is in the top left corner of the table. Then we have the remainders from 0 to 7 at the top. And again, the remainders from 0 to 7 on the left-hand side. You now take your time, multiply the numbers in pairs, convert their answers to mod 8, and put the answers in the correct boxes. Remember, if you don't put the answer at the correct place, the table will be wrong. And so we can see the table completed. Now from the table, we want to find the answer to 7 times 5 into brackets plus 7. Now what do? We have to work what is in the brackets first. In the brackets, we have multiplication. So you go to your multiplication table to find 7 times 5. From the table, you will find the answer in the box is 3. Now we have to work 3 plus 7. So we go now to the addition table and find 3 plus 7. And so you will find that the answer is 2, mod 8. The second question says, find the answer to n plus n is equal to 6. Because the sign is plus, you have to go to the addition table. We go to the addition table, and as you can see, it is n plus n, which means the same number in the first space should be the same number in the second. Or a number plus itself should be equal to 6. So you go to the addition table, and then you check each number plus itself. So check with 0 plus 0. Check 1 plus 1, 2 plus 2, 3 plus 3, all through the table. Now with observation, we find that 3 plus 3 is 6. So one of the values of n is 3. Again, 7 plus 7 is 6. So another value for n is 7. Now these are the only two numbers that add to themselves to give us the answer 6. So our final answer is 3 and 7. But we put them in curly brackets, as you can see. Example 2. Copy and complete this table for addition and multiplication in modulo 5. So this time you're going to use the modulo 5 remainders. And you can see from 0 to 4 at the top, 0 to 4 below the addition sign. Again, you work each number with the other, convert your answer, and put it in the appropriate box. Now from the table, it says find 2 times 4 into brackets plus 4. And secondly, find 4 plus 4 into brackets times 2. The two tables have been completed, and you can see the correct answers highlighted in the tables. Now let's use the tables to answer our questions. Question 1 says 2 times 4 into brackets plus 4. We go to the table, find the answer to 2 times 4 from the multiplication table. That gives us 3. Now we have to work 3 plus 4. So we go to the addition table next, and we get the answer to be 2 in mode 5. Again, we have to use the tables to answer 4 plus 4 into brackets times 2. So we start with the addition table, and the answer to 4 plus 4 is 3. Then we go to the multiplication table to find the answer to 3 times 2. Our final answer is 1. I hope you now understand how to fill the tables and how to use them to answer questions. Let's look at the third example. Draw a table for multiplication in modulo 12 on the set of numbers 1, 5, 7, and 11. Using your table, state with reasons whether or not the operation multiplication is commutative. Then 2, evaluate 5 times 7 times 11. And find the truth set for n times n is equal to 1. Now here we have to be careful. You have to use the numbers given in the question on your tables. We don't use all the mode 12 reminders. In constructing the table for multiplication mode 12, we are using the numbers 1, 5, 7, and 11. So we have those numbers horizontally at the top, and then below the multiplication sign, we also have 1, 5, 7, and 11. Now let's quickly go through the table. You find we have 1 times 1 is 1, mode 12. 1 times 5 is 5. You find the answer right below the 5. 1 times 7 is 7. And 1 times 11 is 11. Again, we have 5 times 1 is 5. 5 times 5, that gives us 25. We change the 25 and we get 1. 5 times 7 is 35. That gives us a remainder of 11. 5 times 11 gives us 55. And in mode 12, we get 7. And when you look along the 7, we have 7 times 1 is 7. 7 times 5 gives us a remainder of 11. 7 times 7 is 49, a remainder of 1. And 7 times 11 is 77, a remainder of 5. If you look along 11, you will find 11 times 1 is 11. 11 times 5 is 35, a remainder of 7. 11 times 7, 77, gives us a remainder of 5. And 11 times 11, 121, gives us a remainder of 1. So our table is completed. Now the first question we are to answer is the operation multiplication commutative? Remember, we mentioned the commutativity in a previous lesson before. I hope you can remember. Any two numbers with an operation, when it's worked in one way, and you get an answer, and you work it the other way by changing the positions of your numbers with the same operation, if it gives you the same answer, then we say that operation is commutative. Now let's see whether we can tell from this table whether the multiplication is commutative or not. So then we can check with any two numbers at a time. Now let's look at 1 times 5. 1 times 5 from the table gives us 5. If we get 5 times 1, we still get 5. If we take 5 and 7, 5 times 7 gives us 11. And 7 times 5 gives us 11. If you take any other number, 11 times 7. 11 times 7 gives you 5, and 7 times 11 gives you 5. And so we can safely conclude that multiplication on this set of numbers is commutative. Now, in the second question, we are supposed to work 5 times 7 times 11. So again, we will work from the left to the right. We will find the answer to 5 times 7 from the table, and that gives us 11. And then we work 11 times 11, which is equal to 1. So our answer is 1. For the third question, we are supposed to find the value of n so that n times n will be equal to 1. Now from the table, you can see that 1 times 1 is 1. Can you find any other number? 5 times 5 is 1. 7 times 7 is 1. And 11 times 11 is 1. And so our answer to that question will be made up of all those numbers. So our truth set will say n is equal to 1, 5, 7, and 11. In our last example, it says draw the addition, multiplication tables for the set K, which is equal to the set of numbers 3, 6, 9, and 12 in arithmetic modulo 15. Then from your table, evaluate I. 3 times 3 into brackets plus 6 times 9 into another brackets. Then II. Find the truth set of n times into brackets n plus 3 brackets closed is equal to 3. Now remember, in forming these tables, you have to add or multiply and change your answer to modulo 15 before writing it in the appropriate box. I'm sure you can see the table completed. Now we want to use this table to answer the questions. So we have 3 times 3 into brackets plus 6 times 9 to a second bracket to give us 9 plus 9, and that equals 3 in mode 15. Now, II says find the value of n if n times into brackets n plus 3 is equal to 3. Now, we do this by observation. So, by inspection, we find that 3 times into brackets 3 plus 3 is equal to 3. 6 times into brackets 6 plus 3 is not equal to 3. And 9 times into brackets 9 plus 3 is equal to 3. Again, 12 times into brackets 12 plus 3 is not equal to 3. And therefore, our truth set will be the two numbers 3 and 9. So we say n is equal to 3 and 9. But remember, we put our answer in curly brackets. We have learned so much in this lesson. The first one is that addition and multiplication tables can be represented with the remainders of each modulo. Our various methods for operations of addition and multiplication, as well as simplifying in the modulos, are used to complete the tables. This brings us to the end of today's lesson, and also to the end of our lessons on modular arithmetic. In our next lesson, we will take a new topic, and that is simultaneous equations. Make a date with us again as we study how to solve simultaneous equations. Bye-bye.